Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I'm dealing with wave mechanics of chemistry. This is lecture number 13. In lecture number 12, I was discussing normalized wave function and orthogonal wave function, but I could not explain you both simultaneously because of the time constraint, and that's why I'm continuing the same topic in this lecture. Okay. So what is normalized wave function? The condition for normalized wave function is given here, that integration of psi square in dx dy dz is equal to integration of psi square dv is equal to integration of psi square dt is equal to 1. That means if psi into psi star or psi square equals to 1, then it is called normalized wave function. It shows that probability of finding electron that is psi square in a unit volume, that is dV, is always equal in all directions, that is 1. Okay, so this is the interpretation of this kind of normalized wave function. Okay, so this is what normalized wave function means, that we can find out electron in all directions and equally. Okay, and if psi square dx dy dz or psi into psi star dx dy dz is not equal to 1, that means probability is not equal in all directions, then such function is called non-normalized wave function. Okay, then psi itself is non-normalized wave function. So psi will be non-normalized wave function. But we can make it normalized wave function by multiplying. So we can make non-normalized wave function into normalized wave function by multiplying psi with a constant a, or we can say n, whatever you say. Okay, then the conditions for so that we can have a new condition. So in order for the new wave function a psi to be normalized, function, it must meet the following requirements. So the condition is this one. A into psi star dx dy dz is equal to a psi star, a psi star into dv is equal to 1. Okay, since a is a constant, it can be removed from the integral part, from the integral sign, and therefore we write a square integration psi into psi star dx dy dz or dv is equal to 1. Okay, or we can write psi into psi star integration dx dy dz is equal to 1 upon a square is equal to a raised to minus 2. Okay, so here a is known as, because it is making this psi non-normalized wave function into normalized wave function, so a is known as a normalizing constant, because it is making a non-normalized function into normalized function. So this is known as normalizing constant and can be determined from the above equation. Okay, so any two eigenfunctions belonging to distinct, that is unequal, eigenvalues of a self-adjoint operator that is psi I and psi j are mutually orthogonal, that means perpendicular. If we represent two different acceptable wave functions of a given system by psi I and psi j, the wave functions will be normalized if they meet the requirement integration psi I into psi star j dx dy dz is equal to 1, or psi j into psi star I dx dy dz is equal to 1, then they are called normalized. On the other hand, if psi I into psi star j dx dy dz is equal to 0, or psi j into psi star I dx dy dz is equal to 0, then they are said to be mutually orthogonal. So it's very simple, okay, that for orthogonal, the sign should be 0. That means probability is 0. And for orthonormal, probability is equal. Okay. And if both functions are orthogonal as well as normalized, then they are said to be orthonormal. So orthonormal functions are like this. Psi I into psi star j dx dy dz is equal to 1. This is when I is equal to j. Sorry, this is not star. And if psi I into psi j dx dy dz is equal to 0, in that case I is not equal to j, then these functions are known as orthonormal. So this is the condition. Equals to 1 is condition for normalized and equals to 0 is the condition for orthogonal. Okay, so this is the case for normalized and orthogonal wave functions. Okay, now we know that if you plot psi or r versus small r distance for 1s, the sign is like the graph is like this, and for psi versus r for 2s, the graph goes like this. So here there is one node and there is no node in 1s. So this way, this is in fact meaningless. But if you plot a graph of psi square versus r, and if this is the graph for 1s, that means probability of finding electron near the nucleus is maximum. And if you go away from nucleus, probability decreases. And here for 2s, the graph goes like this. Here probability is 0, okay, and then it becomes maximum and then decreases. So this is for 2s.